Okay, now let's go ahead. We're going to talk today. This is going to be under, I'll write on the cover of your little foldable here. Under your little foldable here. All right. This is going to be section 6.4. Okay. Inverse trigonometric ratios. Okay. That's what we're dealing with today. Inverse trigonometric ratios. If you want to put them at the top of your notebook, that's fine, but that's what we're dealing with. We're going to talk about today. All right. This foldable is a little weird, so we're going to work with what we got. All right. And we're going to get right into it. Now, we're going to start over here. Okay. Shh. Trigonometric ratios. Please be quiet. Thank you. Trigonometric ratios are, all right, solving for a missing angle. Now, we've already done these before, right? Use this method when, of course, it's a right triangle. Nope, just a right triangle. It's a right triangle. You know two sides. And two angles are two unknown angles. Two unknown angles. Right? Those are the three key things. Okay, that's when you know when to use this method. Okay? Again, I need everyone to be quiet. Thank you. Don't need apology, just need to be quiet. Okay? Now, the steps, of course, are, when we solve for a triangle, are we draw a label. Draw and label a diagram. Okay, diagram is a fancy word for a picture. Okay? We identify the missing angle, label the sides as opposite, adjacent, and hypotenuse. Right? So this is more review than anything else. Okay? Then we determine which trig ratio to use. Finally, the side figures. We plug the value and solve for the angle using the inverse trig function. Okay? So this is where we start to explore the idea that trigonometry isn't no more an operation, but more so an actual variable involved. Just like x, that is when you multiply an x together with 2, you have x times 2 or 2x. To get rid of the 2, you divide by 2. Cosine has its own inverse operations that allow you to undo what you just did. Okay? And also allow you to identify the angle of any given ratio, as you're about to see. Okay? So, first, let's take a look at a physical or inverse trig functions, okay? So, actually, no, we'll do the example first, then we'll do the inverse trig function. So we're going to go back up here. Now, up here at number 1, we have a triangle, right? Bunch of given angles. Lovely. Okay? Now, what we're going to do is we have the hypotenuse over here. Do this in blue. We have the hypotenuse over here. We have the opposite side, the adjacent side over here. Okay? Rats. One second. Okay, we have the adjacent side. Okay, the adjacent side right there. Now, what we have to do is we have to identify which triangle, which thing we're going to use. Yes. The opposite side? My bad. That is the opposite side. Sorry. Yes. Okay, this is the opposite side. Okay? All right. We have sine, cosine, and the tangent ratios, right? Now, which one are we going to use? We're going to use sine, because it's opposite to our angle. Let's call him x. All right? So we have the sine of x equals the opposite, 40 over 42. Now, you guys have done a bunch of these in your homework as well as in practice. And now I'm going to ask you, well, what is the value of x? This is the missing link. Why we can't find, if we knew the height of a building and how far away from the building, we don't know how high we need to, what angle we need to look up to see the top of the building. Well, guess what? Now you're going to learn how to do it. Okay? the first thing you need to do is you're going to do the sine -1 of x times the sine of x. Oh, my bad. Don't write an x on that other one. My bad. Where's my whiteout? I need my whiteout. There we go. Okay, so you're going to do the sine of -1 times the sine. Don't need to use an x. What am I doing? Okay. Times the sine of x equals, and what you do to one side, you have to do to the other side. Sine of inverse, so we put -1 up there, and we do 40 over 42. Okay? What we're effectively doing is undoing sine on x and doing the same thing to the other side. When you do one side, you do the other. Okay? Now, when you do this, what ends up happening is that the value you're going to get out of this x value, is going to be equivalent to whatever this is. This effectively just became an angle. So the inverse of a trig, given the ratio of those sides, is effectively the unsimplified angle of that given side. Does that make sense? So this right here technically is a degree. Doesn't look like it, but it is. Once we plug it into the handy-dandy calculator, which I'm about to show you how to do right now, and I will provide a cheat sheet on how to do this later, but you're going to do the inverse. Now, on the calculator, down here, you'll see where sine is. You'll see blue text at the top that says sine -1. That's inverse. So we're going to do second sine, type in 40 divided by 42, hit enter, and there's our degree measurement. So our answer for x is 72.247 degrees. I like to write in a 3 sig fix. And that's our degree. Now, something you need to know. Okay, I want you to make a note of this. Below this, put a star. You cannot use the calculated degree to find the final missing angle. Okay? And the reason for that is that if I did type in, if I did 90 plus that measurement, and I did 180, whoops, next line. Okay, I did 180 minus that number, you should effectively get the answer up there. Problem is, that's not actually correct. Because when you use calculated values, there's a percentage error because of rounding. Now, I'm using the whole digit, so it should be the same. Give it a couple zeros. One sec. Okay? But just for giggles, I want to show you guys what I mean. So now I'm going to calculate it for the opposite angle up here, which of course we can use cosine to do in this case because adjacent over hypotenuse. I'm just going to plug it in real fast. You don't necessarily need to write this down, but I'm just going to show you why this rule exists, okay? So we're going to do second, so it'd be second cosine of 40 over 42 again. And enter. And we get 17.752. So there is our missing side. Now these are, but look here. On the very end, there's your rounding error. So they're technically not the same. Just a little bit off. But I promise you that that will matter, especially for those of you who are attendance and honors. You will see this come back, and they will care about those decimal points. So you only ever use the given sides in your calculations. Never use the new angles in the new calculations. Okay? Use what's given to you, always. That's what this little disclaimer means. All right? Now, with that stated, put that up here. Let's move right along. Let's take a look at this word problem. A fire department's longest ladder is 110 feet long, and the safety regulation states that they use it to rescue up to 100 feet off the ground. What is the maximum safe angle of elevation for the rescuer's ladder? Okay, so let's draw a picture. Okay? So, I'll use purple for this. We've got side of a building. There's our ladder. Okay. There we go. We've got 100 up here. We have 110 up here. Okay. And we want to find that angle. That's the minimum angle of safety we can use. Okay. So what we have to figure out is we're going to find the sine of x equals 100 divided by 110. Okay. which can then be reduced to 10 over 11. And the reason why we're using sine is because our missing angle is right here. This is the opposite side. This is the adjacent side. And this is obviously a right triangle because we are putting this against a house, and houses and buildings typically have a 90-degree angle at them. Typically. Unless they built on really unstable ground or the side of a cliff. Okay? All right. Now, as always, we're going to do sine inverse, so inverse of sine on both sides. That effectively cancels the sign, so we're left with x equals the sine of negative 1, or to negative 1 to 10 over 11. We type that whole thing into our handy-dandy calculator. Okay, so we have second sine of 10 divided by 11, and we get x equals 65.380 degrees, or roughly 65 degrees. Okay, that's your minimum safety. But I cannot go past that, okay? So realistically, this is more of an inequality, right? That's the maximum elevation, maximum angle I can go. If I go any closer to the wall, it's not safe, okay? Which means that the value has to be, realistically, it would be x is less than or equal to 75.380 degrees. That's your final answer, okay? Does that make sense to everybody? Okay.
Yeah.
All right. Now, Now, when you're calculating just random decimals here, these are just basically just plug and chug in regards to just basically punching them into the calculator, all right? Dealing with the sine of inverse and terminology. So, for example, this first one, we're going to do the sine of negative 1, which is sine inverse. However, there's another wording that you might see on tests and calculators. It's rare, but it likes to be quite frequently used. And that is something called arc sine. Yes, arc sine. A-R-C, arc sine, one word. And what that basically means is, well, again, arc sine. These are the same thing. If you see those words in a question, it's like, what is the arc sine of this angle? It's just saying, find me the inverse of the angle, please. That's all it's saying. It's just another terminology. I just make sure you have plenty of words to understand here. And that holds true for cosine and tangent as well. Okay, for this one, cosine of negative 1 would be the cosine, cos inverse, or cosine inverse. Sorry, those are quotation marks. You'd have arc cosine would be arc cosine. Okay, again, they mean the same thing. And tangent would be also the same. You'd have tangent of negative 1 is tangent inverse or inverse tangent. The wording is interchangeable. You can do inverse tangent or tangent inverse. They're the same thing. Typically, I like to say inverse tangent, but I'm just going to write it like this because I believe this is actually like a little more formal. So inverse tangent or arctan, which just means, again, arctangent. Okay, there you go. So there's your three sets of words there. Okay. So, okay, now we've got the sine here. So we have the sine inverse of sine B equals the sine inverse of 0.2756. Okay, we punch that in the calculator and we should get, now wording wise, I'm going to measure this out, but here's something you should know. You can write the measurement of angle B. That's kind of a shorthand for writing the measurement angle, because remember, this is a measured angle. Anytime you get the inverse of a ratio, we get the measured angle. Okay, so that's just a shorthand of writing it. And we get from that roughly 16 degrees. I want a decimal, though. So we do, let's see, so second sine of 0.2756. And we get, 16 degrees. or roughly what it was, which was 15.998. Okay? Basically what it rounded from. I know I wrote those kind of backwards. I apologize, but you can correct that on your own paper. All right? Again, same thing holds for cosine. If we do the cosine inverse of cosine V equals 0.6820. Okay. Sorry, I forgot to write the inverse cosine on the other term. So we have cosine inverse of 0.6820. Okay. So then we have the measurement of angle C equals, plug that in the calculator. We get, so again, second cosine would be second and then cosine. And that gives me cosine -1. So we do 0.6820. Close it up, enter it. And we get, I'll write it the right way this time. So squiggly equal sign, 46.99. It does round by default, so I'll do 9.8. I'll have to go one more step. 0.99. So darn near close, basically, to 47. Okay? And the last one, tangent. So we do, again, inverse tangent of tangent A equals the tangent inverse of 2.05. I'll rewrite that because that's a mess. Hold on. 2.0503. Okay. Punch that in the calculator. Second tan. We get 2.0503. Close, enter. And we get the measurement of angle A is roughly 63.999. This one rounds quite a bit out. 95. So it should be equal to 64 degrees. Okay? There you go. Any questions on any of those?
No.
All right, excellent. So, that concludes at least the first part of the notes.